our laboratory, we study brain aging. We use the zebrafish as a model organism. Our research will improve the lives for older individuals.
We are synthesizing information processing drugs.
In our research lab, we play with atoms on a daily basis.
In our lab, we do mechanochemistry. We break, shake, and shatter for useful chemical reactions.
We are enlightening static electricity that could not be revealed for 2500 years since the Thales of Miletus.
We can put the real world in a computer and predict behavior of materials that don't exist yet.
Our research on immunopharmacology aims to identify approaches that safely but effectively modulate the immune system to cure deadly diseases.
We are exploiting overactivated signaling pathways to treat cancer.
Our research combines science and technology with novelty, simplicity and practicality.
Humanity has thus far discovered less than 0.1% of all kinds of possible materials. In our research group, we have been developing new material systems and working on their nano-device applications.
We can accurately simulate quantum world with powerful computers.
At our laboratory, we control the behavior of fluids at micro and nanoscale.
In our laboratory, using transgenic animal models and innovative chemical biological approaches, we study the basis of atherosclerosis and myocardial infarction, with the hope to develop novel therapeutics.
In the micro-nano integrated fluids lab, we are trying to generate novel nanoparticles by using microfluidics.
In our lab, we study how tumor cells interact with immune cells. From this knowledge, we will be able to develop better strategies against cancer.
We are doing basic research, that is, to bridge the gap between what is done in the lab with what will be useful for the patient in the clinic.
At Bilkent University, we are developing nanoscale mechanical sensors to weigh and characterize single biomolecules.
The fundamental laws of physics are incredibly simple, but we are surrounded by enormous complexity. Our ultimate goal is to understand and learn how to exploit the emergence of complexity.
We develop inexpensive and efficient inorganic materials that can produce hydrogen from water with using only solar light.
In Precision Manufacturing Research Lab, we design and develop tools and processes for micro and nanoscale machining of engineering materials.
We are in search of materials with unusual properties for their fundamental physics and their applications.
In our lab, we study signaling pathways important in cancer using comparative transcriptomics and zebrafish models.
Photons are everywhere, and we create a very special photon in a laser concept.
Hi, our research is focused on the human genome. We study neurogenetic disorders.
We use nanotechnology to make catalysts for clean, sustainable and affordable energy conversion and storage systems.
We are trying to understand the molecular mechanisms of drug resistance and metastasis in cancer.
In our lab, we are programming cellular functionalities for biomedicine and nanotechnology applications.
We are developing nanotechnology for medicine.
In our laboratory, we design and synthesize nanostructured novel organic materials to be used in the areas of nanophotonics and bio-nanotechnology. In our research group, we develop new synthetic transformations for applications in medicinal chemistry.
We make nanofibers, which are 1,000 times smaller than your single hair, and we look at their application areas.
We are working on next-generation energy storage systems for a more sustainable future.
Building materials serve us for our future.
Our research in cancer biology aims to identify the genes involved in breast cancer development that could be good candidates for diagnosing and determining the prognosis of the disease.